We're doing a little bit of extra practice on implicit differentiation. This is a difficult topic for some, and we use it the rest of the year, so we have to make sure that we know it. It's not just one that you just skip over and you're like, it's fine. It won't be on the AP test. It will be all over it. All right, so it says find the derivative of the Folium of Descartes, which was graphed in the last section. So if you remember, you had this little sketch, and it looked like this. Do you guys remember that? All right, so we're finding the derivative of it. So I'm going to do the derivative of x cubed is going to be 3x squared. The derivative of y cubed is going to be 3y squared times dy over dx. Okay, so we remember whenever we take the derivative of a y term, we need to tack on the dy over dx. Just like when we had like f of x cubed, the chain rule told us that we did 3 times f of x squared times f prime of x, right? That's what we're doing. So implicit differentiation is related to the chain rule. All right, and then equals the derivative of 3xy. We're going to treat it like a product, 3x times y. So I'm going to have first times the derivative of y is going to be dy over dx plus derivative of the first is 3 times y normal. We don't tack on a dy over dx because we don't need it. We weren't doing the derivative of y, right? We're in the notes. All right, so we're going to try to get the dy over dx's on one side. It doesn't matter which side you get them on. Okay, so let's say I subtract my dy over dx term to the left-hand side. So I'm going to have 3y squared dy over dx. I'm subtracting my 3x dy over dx over. So I'm taking this one over here. And then I'm going to get everything that doesn't have a dy over dx on the other side of the equation. So I'm going to have my 3y, and then I'm going to subtract over my 3x squared. All right, so when I do that, I get dy over dx times 3y squared minus 3x. I pulled it to the front, yep. I divide it over, so I get 3y minus 3x squared over 3y squared minus 3x. So Ian's already ahead of the game. Do you guys hear him saying pull out the 3? So all of them have 3 in common. So it's like saying that I have 3, and then I have something in parentheses, and 3, and then something in parentheses, right? So I'm going to divide all of my terms by 3. So you're going to be left with y minus x squared all over y squared minus x. And there is nothing else you can do. There is no GCF that you can pull out to the front. So we can't reduce anything out. All right, so B. So it says find the equation of the tangent line at 1.5, 1.5. So when I'm finding the equation of the tangent line, I need to find the slope at that point. Sometimes you'll see, like on the AP test, maybe they notate things like this. That means plug in 1.5, 1.5 into the derivative. I don't care if you write it that way. You can just call it m. It doesn't matter. So when I do that, I have 1.5 minus 1.5 squared all over 1.5 squared minus 1.5. So some of you might be stressing or pulling out a calculator, as I see Ethan is. And you're like, oh, I got to figure out 1.5 squared. 1 minus 1.5 squared is this. It doesn't matter. Can you guys figure out what it is without a calculator? It is negative 1. Good job, Emerson. How did you see that it was negative 1?
Because on the top is going to be negative.
It's like exactly the opposite of what's on the bottom, right? Does it make sense? It's like saying 4 minus 6 over 6 minus 4, right? They're the same thing, just one's opposite. One's negative. So you get negative 1. Yes, I do know that 1.5 squared is 2.25. Well, can I do the 1.5 minus 2.25? All right, so I have y minus 1.5 equals negative 1 times x minus 1.5, like that. That is our answer. You were just getting ready for the next one. Yes, totally. All right. So then part C, it says, at what point or points in the first quadrant is the tangent line horizontal? Now this is a weird question, and this is why Descartes was interested in this problem. So we're going to get the answer, and then we're going to talk about why this is a weird answer. All right, so when we know that when it says find where the tangent line is horizontal, we're finding when our slope is equal to 0. So we've done that many a time. So we're going to find when our slope is equal to 0. So I'm going to have y minus x squared all over x, or y squared minus x equals 0. Now what I would write, though, first is I would write dy over dx equals 0. Because on the AP test, a lot of times you get a point just for writing that. But if you try to remember it and you're like, oh, it's y minus x squared over x minus y squared or whatever it was. See, I didn't remember it correctly. I wrote it wrong. Right, so I would end up not getting that correct if I said equals 0 and I hadn't put this part. I wouldn't get that point for the setup. Does that make sense? Because I wrote it wrong.
If I wrote something like this,
So what was it?
like this, where I continue on the rest of it.
Yeah, that's fine.
do that,
Yeah, so y squared minus x, is that what's on the bottom? So I was close, just the opposite. Y squared minus x. Okay. Yeah, but the y doesn't have to be on, well, I guess, yeah. Yeah.
It certainly looks nicer if the y is in front.
Yeah. All right. So I feel like that's not what I had in the first class. Now I'm like freaking out that my answer's wrong. I didn't make any mistakes, did I? Were you guys following? That was good. All right. Now I could multiply through by -1, and maybe you do this differently than your neighbor. Maybe you have x squared minus y over x minus y squared. How's that different? Yeah, I flipped both the top and the bottom. So it's like multiplying by -1 on the top and the bottom. So when you're checking answers with a friend, maybe you have exactly the same answer, but yours has a -1 and a -1 multiplied on the top and bottom. So look for things like that when you're checking. All right, so anyway, so I want to know when this is equal to 0, so I'm finding when the numerator is equal to 0. So I have y minus x squared equals 0, so y equals x squared, like that. Okay, so this, y equals x squared, that could be a lot of points. Right? How do we find what that is? So we go back to the original. So go back to your long equation at the beginning. X cubed, I guess it's not super long. X cubed plus y cubed equals 3xy. And we have a system of equations. We have an equation with x and y and an equation with x and y. So we are able to solve for it. So we're going to replace our y with x squared. So I'm substituting n. So when I do that, I get x cubed plus x squared as being cubed equals 3x times x squared. So I get x cubed plus x to the 6th equals 3x cubed. Subtract over, so I get x to the 6th minus 2x cubed equals 0. Factor out my x cubed, so x cubed, and then times x cubed minus 2 equals 0. So when I set x cubed equal to 0, and I set x cubed minus 2 equal to 0, I get two x values. I get x equals 0, and I get x equals the cube root of 2. But the question said what points in the first quadrant. So those aren't points. So one last step, we plug back into either equation. Now, do we want to plug back into the x cubed plus y cubed equals 3xy? No, we want to plug into the easiest equation. Look at this, y equals x squared. Isn't that much easier? So if I plug back into y equals x squared, I get y equals 0, right? So I have 0, 0. And then the other one is going to give me y equals the cube root of 2 squared. What is that? Cube root of 2.
2/3.
It is 2 to the 2/3. You could write it that way. What if I wanted it under a cube root like the other one? I don't know if you guys remember this from Algebra 2, but that square, it doesn't have to be on the outside. I always write it on the outside, but it could be on the inside too. Right? So isn't the cube root of 2 times the cube root of 2 just the cube root of 4? Same thing. So you could say the cube root of 4 as well. It doesn't matter. Whatever you want to do. So we're going to say it cube root of 2, comma, cube root of 4. That would be the other point. So I told you that this is something very strange about this problem because 0, 0 is a horizontal tangent line. So going back here, it's like, oh yeah, 0, 0, that's a horizontal tangent line. That works. You know what else 0, 0 is? It is. It's also a vertical tangent line. Mind blown, right? A point that is both a horizontal and a vertical tangent. Isn't that weird?
We had one of those on the homework.
Yeah, so strange.
I think we've had
You guys
one
see
of
how
those
when I
every
plug in
time
0,
we
0?
get horizontal and vertical.
I don't know.
Every time. It seems like it.
Not many
No,
like
we always
that.
get like one number that repeats.
All right, so this can happen because it's not a function. Okay, so it's not a function. So things that are not functions, that could possibly happen. But it's very rare. So I think that's why it blew Descartes' mind. He's like, whoa.
Would
0,
Descartes
0 still count even if it is not in the first quadrant, or 0, 0
I don't know. Would you count it if it's in the first quadrant?
I would
I don't know. It's not really
I
in
would
the
say
first,
0, 0
first quadrant.
technically, I mean,
I would put it just to be
I would
safe.
think it's in every quadrant.
And then do you guys see the other horizontal tangent line? It's right there at that point. That's the cube root of 2 one. That's where the tangent line is horizontal.
When was Descartes around?
I should know.
This sounds like stuff that they figured out a long time ago.
They did. All right, so dy over dx. So we're finding dy over dx at the specified point. This is just like your homework problems. These should not take you very long. So let's try it. So be an active note taker. Try along with me. See if you get it. So you guys have 2x plus 2y dy over dx equals 0. Did you guys remember equals 0? Did any of you put 9? A lot of people will put 9.
Do we have to put equals anything?
You do. It has to be an equation. Otherwise, you won't be able to solve for dy over dx. All right, now we plug in 2. So we're going to have 2 times 2, and we're going to plug in root 5 for y. We're going to subtract the 2 times 2 over, so I get negative 4. I divide by 2 root 5, so I have negative 4 over 2 root 5. Okay, I probably wouldn't leave it like that. I'd reduce it a little bit. Divide by 2. Yeah, so negative 2 over root 5. You can leave it like that, or if you were feeling fancy and you wanted to rationalize, you could.
Do you need to for the AP test?
Nope. Once you're in calc, we don't care. You can leave it as a square root on the bottom. All right, so then write the equation of the tangent line. So we have the point 2 comma root 5, so it'd be y minus root 5 equals negative 2 over root 5 times x minus 2. That is our answer.
When you get to the higher level of math, why did you figure out before?
It's kind of like, you know how when you're in Algebra 1, well, even pre-algebra, I guess, you always wrote things as like 1 and 2/3. And so you'd have 1 and 2/3 times 2 and 3/5, right? We don't ever write things as mixed numbers once you get into Algebra 2 and so on, because it takes a lot of time. If you're multiplying those, we'd rather see them as improper, right? So we just leave them as improper. So it's the same concept. At certain points, you just stop doing certain things.
So they're like more to help illustrate the concept than tell you concept.
Yeah, it's because, you know, people in pre-algebra don't know that like 11 over 5 is 2 in something.
2
Like
and
they
1/5.
need to write it like that to see that it's 2 and 1/5, right? All right, so we take the derivative here. So this is derivative of sine is going to be cosine, so I have cosine of x. The derivative of cosine of y is going to be negative sine of y, and then times dy over dx. Notice how the argument is the same. If it was cosine of y, then I'm going to have sine of y. Yep. So keep your argument the same. It's never like negative sine of dy over dx. Like you can't have the of part being the dy over dx, okay? And then equals 0. So you can get the dy over dx by itself right now, or you can plug in the point. I usually plug in the point. So I'm going to plug in 0, and I get cosine of pi over 2 minus sine of 0 times dy over dx equals 0. Do you see something weird happen? You get 0 equals 0. So it's like, wait a second. What does that mean for a slope? Right? So if you had solved this one for dy over dx, you would have gotten negative cosine of x divided by negative sine of y. So when you did plug it in, you would get 0 over 0. So the slope is undefined. Okay, so slope is undefined. All right, so it is a point, but there is no slope there. So I don't know what's going on. It could be like a vertical tangent. It's definitely not an asymptote because there is a point at pi over 2 comma 0. If you plug that in, it does work in the equation. All right, so the next one. So solve for y dy over dx using implicit differentiation. So same stuff. Yeah, Alex?
Could you like gotten dy over dx equals like sine y over cosine x and plug them in?
Yep, sure. Yep, you would get 0 over 0. So that's when we would say, oh yeah, it's definitely undefined then. 0 over 0 is undefined. All right, so I'm going to have 5y to the 4th. It's a y term, so I tack on a dy over dx plus, uh-oh. Do you guys see its product rule? At least it's not quotient rule. All right, first times derivative of the second is 3y squared dy over dx plus derivative of the first is 2x. Second one normal is y cubed. Equals 0. Did you guys all see that's 0? Derivative of 1 is 0. Plus product rule. First is x to the fourth. Derivative of the y is dy over dx. Plus derivative of the first is 4x cubed times y. Little messy. So we have 5y to the fourth times dy over dx plus 3x squared y squared times dy over dx plus 2xy cubed equals x to the fourth dy over dx plus 4x cubed y. So a lot of these steps I kind of do in my head, and you guys are going to get to the point where you're going to be able to do a lot of these steps in your head. So the next thing that I'm going to do is I'm going to get every dy over dx term on one side of the equation. So I'm going to subtract dx to the fourth dy over dx over. And then the thing that I typically do in my head is I pull the dy over dx out as I'm doing this, because we don't want to keep writing all of these steps over and over and over. So once we get all the dy over dx's on one side, we're going to pull the dy over dx to the front. So I'm going to have 5y to the fourth plus 3x squared y squared minus x to the fourth.
And you divide
Yeah, I've got to take this one over.
Divide 4x cubed y minus 2xy cubed by that whole thing.
Uh-huh. So I'm going to subtract my 2xy cubed to the right-hand side. And then to get my dy over dx by itself, I divide that whole parenthesis part over. Did you guys start to get the hang of that on your homework? Were you guys like, ugh, getting sick of writing the dy over dx? And then sadly, there's nothing that we can reduce down by. I don't know if that's sadly. You guys probably like that there's nothing we can reduce down by, right? So we're good. So you can check. There's x's on the top, but there's not an x term and everything on the bottom. There's y's on the top, but there's not a y on everything on the bottom. So we're good.
You don't need to simplify on the AP test because you risk like simplifying.
I wouldn't say you never simplify, but they probably would count it correct most of the time. All right, so sine of x plus cosine of y equals sine of x times cosine of y.
This is fun.
So we're going to do derivative of the first is cosine of x. Derivative of the cosine of y is negative sine of y dy over dx. And then we do product rule. So first is sine of x. Derivative of the second is negative sine of y dy over dx. Plus derivative of the first is cosine of x. Second one normal is going to be cosine of y. So we get all of our dy over dx's on one side. So it doesn't matter which side you get them on. So let's get them on the left side. So I'm going to add, did you guys see how this is all together? Negative sine of x, sine of y, dy over dx. So I'm going to add the sine of x, sine of y, dy over dx to the other side. So I'm going to have sine of x, sine of y, dy over dx, minus sine of y, dy over dx, equals cosine of x, cosine of y, minus cosine of x. Are you seeing all the steps? So you would then pull out the dy over dx. When we pull out a dy over dx, what would we have left in parentheses? Right, sine of x, sine of y, minus sine of y. So I'm going to divide that over. So I'm just going to go ahead and do that. So I have cosine of x, cosine of y, minus cosine of x, all over sine of x, sine of y, minus sine of y. Okay, I will leave it like that. Do you see that there is a GCF on the top and a GCF on the bottom? You could pull out, so you have a cosine of x in common, so then it'd be cosine of y minus 1, and there is a sine of y in common, so then you'd have sine of x minus 1. However, you cannot do anything here. You cannot write this as cotangent. Why can I not say cotangent?
X and y.
X and y, the arguments are different, right? So you can't say cosine of x over sine of y is tangent or cotangent of anything.
Also, they aren't on their own, so you
Well, you could, because you could break apart the multiplication. All right, last one. Ready? Power through. All right, so what does this notation mean? Do you guys remember? d2y over dx squared?
You do it twice.
Second derivative, y double prime. It's exactly the same as writing y double prime. It kind of goes back to that Newton versus Leibniz notation. All right, so there are a couple things you guys could do here. I'm going to go ahead and I'm just going to take the derivative implicitly. So the derivative implicitly is going to be 0. So the derivative of 1 is 0. And then I have negative x times y. So when I do negative x times y, I'm going to have first is negative x, derivative of the y is dy over dx, plus derivative of the first is negative 1 times y. Equals the derivative of x minus y is going to be 1 minus dy over dx. We get all of our dy over dx's on one side, so I'm going to add my dy over dx over. So I get dy over dx minus x times dy over dx equals 1 plus y. So when I pull the dy over dx out, what would I have in parentheses? 1 minus x. So I'm going to divide that over. 1 plus y over 1 minus x. Are you guys okay with me doing that as one step? I need to show it. This is really dy over dx times 1 minus x. All right, that's the first derivative. So this is all y prime. Now we do it again. So I'm going to do d2y over dx squared, or if you don't want to write that, just write y double prime. Same thing. And what do I use? The answer from the last one, what rule? The quotient rule. So I do low d high is dy over dx minus high 1 plus y. D low is negative 1 all over the square of what's below, 1 minus x squared. The derivative of 1 minus x is negative 1. So the derivative of negative x is negative 1. It's the d low. No. So the low is 1 minus x. The derivative of 1 plus y is just dy over dx. Low d high minus high d low. The derivative of 1 minus 1x is just negative 1. All over the square, what's below? Got it? All right, so now what do we do? Do you think they leave it like this? No. dy over dx, we put that in. Now this is kind of lucky though. Look, we have 1 minus x times 1 plus y over 1 minus x. That was very lucky. It usually doesn't happen like that. And then we have a negative 1 times negative 1, so we get plus 1. So I get plus 1 plus y all over 1 minus x squared. So the 1 minus x's cancel. This exact one, really? So I get 2 plus 2y all over 1 minus x squared. So that's the second derivative. Okay, you know what's going to make you guys hate life? There is a shortcut on this one. So this is always like, I always like to think, is there an easy way to solve the problem? There actually would have been here, because you could have gotten the y's on one side. So let's say I added the xy over and subtracted the x over. Do you guys see how you can pull a y out? And then you divide by it. So if you divide by it, you get 1 minus x over x minus 1, which we know is negative 1. All of this works out to be negative 1. So it works out to be negative 1 because if you plug in what we just had here for y, a lot of things are going to cancel out, which is kind of crazy. So y is equal to, well, y is equal to negative 1. I guess the derivative, actually the whole derivative isn't negative 1, it's 0, right? So what would happen here is you'd get 2 minus 2 times negative 1 all over 1 minus x squared. So you'd get 2, oh, I didn't minus there. It should be plus there. So 2 minus 2 is 0. So all of that would work out to be 0. So look for things like that as well.
So you divided the x's on both sides by y?
I pulled out the y. So I have y equals, and I divided that over.
1 minus xy equals x minus y. 1 minus x equals x. Where did you get the y on the yours?
I moved things around. I subtracted my x over and I added my xy over.
Um,
So yeah, that's kind of a weird one. So you could have also done that. So then you would just get that the derivative is equal to 0 right away.
Can we ask some questions?
So kind of weird.